Okay, we're going to take a look at two questions from activity 4, the solubility constant. I'm going to do question number 2, and then I'll go on and do question number 4 as well. So the terminology here is a little bit different. It says the solubility of barium sulfate is 2.4 times 10 to the negative 4 grams per 100 milliliter of solution. Calculate the KSP of the solution. So the first thing we need to do is obviously start with balanced chemical equation. So we've got barium sulfate, and that's solid, and our equilibrium expression, our equilibrium equation, plus 2 aqueous ions, and then SO4, 2 negative. Okay? And it says our solubility, which is X, is 2.4 grams per 100 milliliters. Sorry, that's 2.4 times 10 to the negative 4. Okay. And we are trying to find the KSP of the solution. So the first thing we have to do is convert grams to moles. So 2.4 times 10 to the negative 4 grams of barium sulfate. Molar mass of barium sulfate is 233.39 grams. So that's going to cancel. That gives us 1.03 times 10 to the negative 6 moles of barium sulfate. And concentration then is going to be 1.03 times 10 to the negative 6 moles divided by 0.10 liters, and that's going to give us 1.03 times 10 to the negative 5 moles per liter, or molarity. Okay, so that's our solubility, and that's really X. Okay, so we know that the KSP expression is going to be barium ion and sulfate ion. Because it's a 1-to-1 mole ratio, then that's really just X times X, which is X squared. So our KSP then is just going to be 1.03 times 10 to the negative 5 squared. And obviously we don't care about the units in the KSP value, but that would come out to 1.06 times 10 to the negative 10. So therefore the KSP is 1.06 times 10 to the negative 10 for barium sulfate. Alright, number 4 is kind of the opposite of number 2, and it says if the solubility product of lead nitrate is 3.6 times 10 to the negative 3 at 25 degrees Celsius, calculate the solubility of lead nitrate in grams per liter. So KSP 3.6 times 10 to the negative 6. So again, we're going to start with a balanced chemical equation. So this time we have PbNO3 solid, in equilibrium with lead ions and 2 moles of nitrate ions. Okay. So we can do a very quick modified ice table. Since this is a solid, it really makes the ice table much quicker. All we're really concerned about is the change in our products. So really this is X and this is 2X. Okay, so our KSP then, in terms of our ions, is going to look like that. Okay, and if we substitute in X and X, we're going to get X and 2X squared, which is really just 4X cubed. So we're given the KSP, which is 3.6 times 10 to the negative 3 equals 4x cubed. X equals the cubed root of 3.6 times 10 to the negative 3 all over 4. And when you solve, you get 9.65 times 10 to the negative 2. Now that is the solubility, so that is in moles per liter. So we do care about units there. So if that's the solubility, in other words, and if you want, you could just call that, maybe you prefer to use moles per liter. So how do we convert that to grams per liter? Well, very simple. All we have to do is convert moles to grams. So 9.65 times 10 to the negative 2 moles in 1 liter. And if we multiply by the molar mass, 331.2 grams of lead nitrate per mole. Moles cancel, and we end up with 32 grams per liter. Therefore, 32 grams per liter of lead nitrate. So there you go.